So for today, we will do an example of uh, multiple linear regression using Statistica. And the following are our data set. So in here you can see that there are several variables. These are scores of 12 graders on a standardized test in different areas. So we have geometry, reading, drawing, and on calculus. So more or less, these are their measures of how well they are or how competent they are in these particular subject areas. Now, let's conceptualize this problem as such. Let's take, for example, calculus as our outcome variable or our dependent variable, and we'd like to know whether the performance of the student in calculus based on a standardized test can be predicted by their performance in geometry, reading, and drawing. So that is to say that if we know how much these students perform rather in geometry, reading, and drawing, can their performance in these subject areas be predictive of their performance in calculus? So their performance in geometry, reading, and drawing will be our predictor variables. So we have three predictor variables, all of which are continuous variables, and we have one dependent variable or outcome variable, which is also a continuous variable. So with that, we can perform multiple linear regression. Okay. Now, before we do the regression analysis, it's important also to look into the correlation of these three predictor variables. Ideally, they should not be correlating very high. Meaning to say, if they're correlating at around correlation coefficient of 0.8, 0.9, it might not be good because that would bring about multi-collinearity issues. All right. So for the meantime, for the purpose of this demonstration, let's just assume that they do not strongly correlate. These predictor variables do not strongly correlate. Okay. So let's now perform our multiple regression analysis. Let's click on Format. Statistics, and then multiple regression. Then let's identify our variables. So our dependent variable, the one we are predicting, is their performance in calculus, and our predictors or our IVs are the following. So their performance in geometry, reading, and drawing. Okay. So let's click on OK. Click on OK again, and then click on the summary regression results. All right. Now there are two things that we'd like to look into when we do multiple regression analysis. One is the significance of the overall model, meaning to say, overall, as a whole, do these set of independent variables predict our dependent variable, which is calculus? And that basically is shown in these information. And second, we'd like to know, aside from the significance of the general model, of the entire model, which is these three predicting our dependent variable, the other question would be, individually, which of these three IVs or predictor variables really contribute or really predict our dependent variable, which is their performance in calculus? So those are the two things that we will look into. All right. So there are some information here that you'd be interested to know. So first we have R, which is our multiple correlation coefficient. So this value is a correlation coefficient that basically tells us how much do these three as a whole correlate with our outcome variable. Okay, so that's multiple correlation coefficient. Now r squared, and probably some would suggest that adjusted r squared would be a better value, or a better data to use. Basically accounts for or describes how much variance in calculus is accounted for by our model, by the three as a whole. All right, and this is suggesting that since this is in decimal points, we can convert this into percentages to percentage rather, by moving our dot here 2 places to the right. So 0.68109, so on, can be in percentage would be 68.1%. So this basically suggests that 68.1% of the variance in their scores in calculus is accounted for by the model, by these three as a whole. Again, 68.1% of the variance in the scores in calculus is accounted for by the model, which includes all of these three predictors. Okay. Now we might ask, is that a significant variance accounted for by our model, by these three predictors? So to know that, we look into the F test that was performed. So you can see here that the probability value is very much less, or much less than 0.05. So that means to say that our r squared, or our adjusted r squared, is significantly different from 0. That the model as a whole is really predicting the performance in calculus. So this is the evidence for that, and the p-value for the F test that has been performed. All right, so we've answered our first question. Now the next question would be, which of the three IVs, or predictor variables, really is predicting the scores in calculus? Okay, so we have here first the intercept, which if you watch the previous video, basically describes particularly for the unstandardized regression coefficient, basically gives us a value that is an estimate of what the value of calculus is if all of these are 0. So if they performed so poorly on these geometry, reading, to the point that they scored 0 in all of them, then their estimated performance in calculus would also be 0, perhaps even lesser than 0, because the regression coefficient here is suggesting a negative value. So it's even worse than 0. All right. Now, so again, these are the information we have. So let's review them. So this is your beta, or your standardized regression coefficient. This is your unstandardized regression coefficient. All of these values are in the original units of the raw of our scores, which is the scores in their school, in the test that they took for these different subject areas. And then there is a t-test that is performed, and we'll talk about it later on, and then the probability value. Okay, so first we can see that among the three, the ones highlighted, the ones that are in red, is geometry and drawing. And if we look at their respective p-values, so for geometry it's less than 0.05, which is 0.008, and for drawing the p-value is 0.003, which is also less than 0.05, which means to say that these two are significantly predicting calculus. Okay, all right. Now, so how do we interpret this, particularly for geometry and reading? Okay, so by the way, remember that when we are talking about, let's say for example, geometry, and if it does predict the performance in calculus, that is in the notion that that reading and drawing are both controlled. Okay, all right, and that goes for the others. All right, so how do we interpret this? So for the unstandardized regression coefficient, basically this is suggesting that for every, or provided or given that reading and drawing are controlled, for every 1 unit increase in geometry, there will be a 0.5 increase in points in calculus. Again, provided or given that reading and drawing are controlled, for every 1 point increase in geometry, there will be a 0.52 increase in calculus. All right. Now, what about the other one, drawing? Provided that geometry and reading are held in constant, for every 1 point increase in drawing, there will be a 0.511 increase in calculus. So that's the estimate. Again, given that geometry and reading are held in constant, for every 1 unit increase in the scores in drawing, there will be a 0.511 increase in the score in calculus. All right, so that's how that's our estimate, judging from these coefficients. Now, there would be no point to make sense of this, because this is not a significant predictor. In fact, it might even be suggested that you run another multiple regression coefficient, a revised model, excluding reading, because this is suggesting that reading is not a significant predictor. So perhaps you can do a new analysis, a revised model, wherein reading is no longer included, wherein you only include geometry and drawing, because they are the only predictors that are significantly predicting calculus. Okay. So just for you to know, how did we arrive at this p-value. So these unstandardized regression coefficients are converted into a standardized regression coefficient, to standardized regression coefficients, and these values are compared to 0. So when we compare them, we perform a t-test, such as these. So these are the t-values, and we judge these t-values in terms of their probability. So these probability suggest whether or not these standardized regression coefficients are significantly different from 0. And in the case of this particular example, this is significantly different from 0, with a p-value of 0.008, and this is significantly different from 0, with a p-value of 0.003. But this is not significantly different from 0. All right, so we need to say this is not predicting the scores in calculus, which to me, if you come to think of to think about it, is reasonable. We know that geometry and drawing intuitively would seem to be really very much relate with one's performance in a mathematics subject such as calculus. All right, so that is multiple linear regression using Statistica.